So, welcome to episode 4 of Absolutely Zero Knowledge. And I'm welcomed by Houman and Wyatt, who are both from ICME. We'll get straight into it. There's no need to introduce myself anymore. Do you want to give very brief introductions to yourselves, guys?
Sure. My name is Houman Shadab. I'm a co-founder of ICME. My background is in law and startups and technology. I have been in the blockchain space since 2014, focusing on things like smart contracts and smart legal agreements. With ICME, I'm very excited to be focusing on the future of Web3 through zero knowledge proofs.
Awesome.
Yeah, I'm Wyatt. I'm the technical co-founder. I am a serial entrepreneur. I did a few different things before this. ICME actually started as a no-code/low-code Web3 suite, and we were trying to help salespeople and legal people kind of jump into Web3 because I was doing a Web2 startup before this, and getting back to Web3 even as a developer was very challenging for me. So just imagining the overhead if you're not a technical person is kind of where the idea from ICME came from. But what we ended up happening was there's actually a bunch of requests for zero knowledge proofs. And rather than doing like manual work for each one, we decided to do our own ZK framework and ZK VM. And that's kind of how this whole thing started about a little bit over a year ago. So we're very focused now on this work. We'll probably talk a little bit more about that thanks.
Absolutely, we'll dig deeper. I'm not sure I've asked before, but how did you two have a relationship before? How did you two come to work with one another and found ICME?
We both applied. Go for it.
Yeah, you can go.
Yeah, no, we both applied for a grant from the Definity Foundation when they first launched the Internet Computer Mainnet. And one of us actually got the grant, one of us didn't. That's why he got it as a coder. And so we had a very similar idea, though, about no code and Web3. And so we kind of connected from that.
Awesome. And things seem to be working or going all right between the pair of you so far. And do you want to give a bit of an overview then of the business and what it is, what your angle is, I guess, within zero knowledge?
Yeah, I think the way people think of zero knowledge in general are three different things. One is scalability, one is privacy, and the other thing is verifiable computation. The most you'll hear about are things about scalability, like all the ZK rollup, ZK EVMs are all about that. There's a few privacy projects out there that are also trending, but I think the least well-known is actually verifiable computation. We strive to build a very portable ZK VM and ZK framework that does all three of these things. So it's not just for scalability, it's not just for privacy, it's not just for verifiable computation. You actually do all three. And we do this by combining kind of two technologies. One is Lasso, which is a newer proving scheme that's very fast. And then the back end with Nova, which is a folding scheme, which is very space efficient. And with space efficiency, we run the stuff on a bunch of different types of computers and devices, not just special hardware. So the mixture of these two things and also getting these verifiers on chain is kind of what we're going for. So if in the dream world, ZKPs are everywhere, or ZKPs are very, very fast, we hope to make them or help them become everywhere. And that's kind of where we're going with the tech. Houman, you might have something else to add.
Yeah, I mean, like a lot of people that were into blockchain, from the somewhat early days, we'd probably heard about zero knowledge proofs first from privacy coins like Zcash. I remember meeting Zuko at a conference, and he told me about Zcash, and that's where the Z comes from, obviously. Didn't think too much about it. And more recently, as Wyatt mentioned, a lot of new interest in ZKPs for not just privacy, but also scaling, and now additionally verifiable compute, in part because of the added research and development and investment in the space. I certainly think what we're doing is at the leading edge. But also, maybe as a fourth point too, I would throw in there, at least from my own viewpoint, is decentralization. That ZKP, maybe it's obvious, maybe it's implied, I'm not sure, but is part of, I think, the ZKP story is to help further decentralization. Because if you don't share information or detail or funds or passwords, you don't centralize those things, including control of those things. You keep them local and private. And that's part of the whole decentralization story, I think, and enabling kind of you share what you want when you want. And from a regulatory point of view, which we'll get into, if you're a company and you don't have people's passwords and you don't have people's money, you just have proofs of those things, then you're a different kind of company. You may not be regulated. So I think that's an interesting point of view about the ZKP also.
Okay. And yeah, speaking to founders, engineers like yourself, we've learned, especially on this podcast as well, a little bit around the scalability factor. I think the privacy and sort of security within zero knowledge proof is fairly self-explanatory. But do you want to touch upon very quickly a little bit about verifiable computation? I think that would be interesting, certainly for me to learn a little bit more about, but also some of the listeners as well who might not have, might not be so in the loop on that one.
Definitely. This is something that I think researchers have been striving to get done for a very long time. Microsoft, et cetera, big companies really want to get done. And one reason why is because you're paying, or a lot of people are paying cloud providers to do certain tasks. And it's very hard to prove that those tasks were done correctly. And this is very apparent with something like AI, when you could pay like a specialized company a few $1 million to train an AI for you, and you get weights back as a result. But how do you know they did the training correctly? So this concept of verifying what's being computed is very important for that type of work, but it's also important for decentralization, like Houman mentioned. The one I always like to bring up is WorldCoin. Like they have the orb thing where you put your face in, it scans your iris, which is kind of pretty intrusive in my opinion. And also you have to go on site and do it. If they're able to verify compute locally rather than in the orb, they could have ran the ML model just on your machine. You could have used your camera, could have scanned it, and you could have proved the fact that you ran that correctly with verifiable computation, removing this like really obtrusive device that you have to go and see. So those are the type of things that we think verifiable computation are good for, but it's, I would say, a panacea of different things. There's so many different use cases that it's potentially good for. It's pretty amazing, actually.
And in terms of the product itself, then we've obviously touched on a few of those things, but what are you building? I know it's around the sort of super fast provers, but do you want to give a little bit more about, I guess, the technicalities of the product if you can, and I mean, I guess the end users, who ultimately is this platform going to be used by?
Yeah, the end goal for us is actually building a decentralized prover network. But before we can do that, we need to make ZKPs portable enough to work on most machines or many different machines. And this requires a few different things. The way we see the history of ZKP was, first, people wanted very fast verifiers so they can host this stuff on Ethereum and other blockchains. And we've done that. Graph 16 is a great example, which most people use to get the stuff onto Ethereum. The second thing was faster provers. Like research recently has been all about how to make provers extremely fast. There's a bunch of work on it with Fry-based, Stark-based systems, and there's also a bunch of work with these elliptic curve-based systems. But after you have extremely fast provers and extremely good verifiers, how do you make this stuff portable? And that's where our specialty is how do we get this to move from specialized servers to basically anyone's servers? So use cases like a ZK game is a good use case. There's something called fog of war. You can have an item locally and you don't want to expose it on chain. So if you're a ZK game company, you can use our product, not have to learn ZKP or not have to hire ZK professionals directly, and you can, if you're a regular Rust developer, basically code something up. In the background, what will happen is it will run this ZKP in the browser or in our decentralized prover network, and that's what will be hosted on chain, so you can keep the item secret. But really what's cool about that is these users have computers that have GPUs that are super powerful, and normally they can just check a box and they're joining this network, and by just joining it, they're getting tokens in return. So without any extra cost to them, they're actually making some money by joining the network. So that's the whole idea and the end goal for us, for sure.
And
one of the through lines. I was going to say one of the through lines for ICME initially is no code, but the idea still stands in the sense of making something more accessible to builders and developers. And certainly one major goal of ICME is to make ZKP tools and tooling and development much more accessible, at least to a much broader range of software developers, and not necessarily the folks that learn the very specialized development, including hardware aspects of ZKP, because we are overcoming a lot of the hardware dependency of traditional ZKP systems by enabling to run client side, essentially in your laptop, on your phone, and that type of thing as well. And that also comes to, I think, general movements right now in technology that are kind of pushing back against the centralized SaaS model. Because SaaS, in some respects, is another way of saying running on a big corporate cloud, as opposed to your device. But if we all have these really powerful laptops now with extra space, why not use it for a decentralized network, maybe Satoshi's original vision, maybe something else, and put it to use for a decentralized network of decentralized technology? Because frankly, not all ZKP systems are truly decentralized. Some ZKP systems you have to rely on a centralized set of computers or even a centralized API to do the ZKP stuff. So we're trying to really be a decentralized system for decentralized technology, in addition to actually private. Not everything that calls itself a ZK is actually private. And Wyatt can talk about that as well. Because oftentimes it's just about scaling, not about privacy.
Mm-hmm. And I mean, you've mentioned there in terms of sort of accessibility, for example, and that's something, whether it's developer tooling or actually the infrastructure itself, or something that's ultimately going to increase the efficiency or the speed of building circuits, for example. But do you think that's reflective of where we are with zero knowledge at the moment? I appreciate we're very much in the infancy of the technology, really, in layman's terms. But there seems to be a lot already around those sort of factors I've just mentioned in terms of improving the efficiency of it. Do you think that's, what's the reason for that, and why is there so many trying to, I guess, tackle that issue?
Even today, if you want to get into ZKP, you need to learn basically like a custom programming language, Circom, Starkware, whatever it might be, Noir. There's a bunch of different languages, a bunch of different things you would have to learn. And I think what most people today are doing in production are the lowest hanging fruit type things, like, hey, Starks already exists. There's a bunch of developers who know Starks and Fries. Therefore, let's use that for whatever we need to use it for, or Halo 2 or whatever might have been in production for a little bit. So all the systems you see are actually, they were started designing like 2019, 2020. So they're actually slightly older systems. And in ZKP, like every month, there's something like a big, huge announcement about a cutting edge ZKP scheme. And I think just the entire way we think about it, we're not a scalability startup. We're not out there to scale Ethereum. So we have kind of a different way of thinking about things in general. When we see something new come out, what we see is hey, we can take that as a verifier and use it as a opcode in our ZK framework, and we get the benefits of whatever that system may be. So say it's a ZK ML system, so a ZK AI type system. We're not specialists in that, but a team might make a system that has that. And all we have to do is make it the verifier work with our stuff, and then you can have that as an opcode. So it's kind of like Ruby on Rails, if you remember that. There's a lot of gems of plugins that you can plug in and play. That's very cool for developers trying out a bunch of different stuff in ZKPs.
Mm-hmm. And I mean, a lot of the stuff you've mentioned has been, within blockchain or on chain. But you mentioned there about ZKML and AI, for example. What's the plan for you guys, or maybe more broadly, where do you see zero knowledge technology going outside of the Web3 industry? Is it going to blow up and evolve massively in the coming years?
I'm going to let Houman take that one.
Yeah, I mean, we're certainly betting on it, and I think so, because as everything becomes increasingly reliant on algorithms and trusting computers to give you a very important result with respect to finance or your personal decisions or lending decisions, or of course healthcare too, people will want to keep all that information and data private and make sure it accurately and correctly executes. And I think ZKP, for both those purposes, is going to become very important and increasingly recognized. So, in terms of AI in particular and ZKML, is certainly a focus point of what we're targeting in terms of our technology and partnerships and go-to-market, because we see a really big opportunity there, and we're building our technology certainly general purpose, but also so it can be used for those purposes. What we call maybe secure AI or verifiable AI or compliant AI. Ethical standards are being suggested or imposed depending on your jurisdiction. Right, the EU just recently passed some AI regulation or legislation, as the case may be, and so I think AI is going to go through a similar phase of crypto in terms of public awareness and pushback and regulation and what have you. But ZKP, I think, will be a very important part of that story to say, yes, this AI algorithm is not discriminating when it makes decisions about what people can do and where they can live and what funds they have access to, what schools they go to, that type of thing. So ZKP, we see really as an important part of that story, and we're excited to be developing for that.
I mean, you touched upon it just there and earlier on in the conversation, but do you see the sort of the legal and the compliance sector, so to speak, being a real area where zero knowledge can help out? Is that a main focus, do you think, maybe for you guys or more widely?
Yeah, I do think it's going to be an increasing focus. I mean, it is. Just a week ago or a couple weeks ago, time flies. I was privileged to be on a panel with other people in the space, some leaders in the space at the ZK Proof conference in Washington, at which certainly policymakers and people interested in regulation attended, in addition to engineers. There, with the focus being on privacy and privacy compliance, but certainly verifiable compute was a topic of discussion. And I think regulators actually have and do understand the importance of ZKP. For example, the Treasury Department in its March 2023 report on decentralized finance, on DeFi, noted by name zero knowledge proofs as a potential technology to enable people to comply with anti-money laundering and know your customer regulation while still maintaining privacy. I think people are increasingly understanding that technology and crypto in particular enables a whole new type of activity, including potentially bad activity, but good activity too, and trying to figure out how to properly regulate while not clamping down on innovation, if that's possible. To some extent, I think people just have to recognize that people can transact privately with ZKPs in a way they probably couldn't before. So Bitcoin is like easy, right? Relatively easy to find people, but with privacy-related transactions, ZKP ones, Tornado Cash, Zcash, whatever, it would be much more difficult, I think. And I think regulators are having trouble doing that. Just recently, in December 2023, on the 11th, I think yesterday or a few days ago, Senator Warren proposed a bill, U.S. Senator Warren, that would really impose basically transparency requirements on every user of cryptocurrency, even if you have your Raspberry Pi mining Bitcoin or somehow contributing to the network. So that kind of idea, the pushback, I think, is reflective of the greater tension in our society between privacy and freedom, or privacy and the ability just to do business online and still stay regulated. So the ZKPs, I think, are going to be part of that story because they are, in a way, very, very privacy enhancing, bulletproof technology in that respect. You can't really peer through. But the fact that regulators are somewhat respecting of them or recognizing their potential use, I think, is important. And there's been numerous proposals from practitioners, engineers like Vitalik, Buterin, and a wide variety of others about how ZKPs can kind of get the best of both worlds as well.
Mm-hmm. And I guess on the flip side of that, and apologies if this is daft, I always put a little disclaimer to apologise if I'm asking a daft question, but on the flip side of that, is there an angle that could say, zero knowledge proof, for example, in the privacy side of things, can hide, quite useful information in the sense of, for example, let's say that zero knowledge proof is proving you've got a certain sum that could make a transaction, but it hiding all the information around that. Is there potential that there could be hidden some quite, harmful data or data to prove that money is from ill-gotten gains, whatever it may be? Is there a chance that quite important data could be missed, whether it's criminal activity or whatever it may be, and what's the stance on that?
I think that is far, far out of the reach of what we do as a startup. The privacy, people are really focusing on privacy, have to deal with that from the very start. Like, their systems need to be thought about very clearly. I think Tornado Cash is the best example. Like, they just said, hey, let's do ZKP for privacy, and whatever happens, happens. And obviously regulators did not like that. Who are building these systems, they need to keep that in mind as they're building them. And it's privacy preserving. You can do a lot of things with it, but it's not the only thing that's privacy preserving. You can use VPNs, for example. There's a bunch of different stuff that we already have in existence that does kind of the same things, but it's really what it's used for that's important. So it's a hammer, and what are you going to use the hammer for? It could be a weapon or it could be a tool. It's really up to the end users. One other thing I wanted to note on that, though, is the fact that as these things are more understood, it makes it easier for regulators to regulate. And I think at the very beginning, we're going to have a few things like Tornado Cash that pop up that make people wake up and realize what ZKPs even do, what they are. But ideally, in the end game, like the end game for ZKPs, it'll be running in everyone's browsers in the background, and you won't even know it's there. So that's like kind of where I think as a technology, we'll probably see it. You might get like a checkbox in the browser that says, hey, this is verified with ZKP, or you show that you did this with ZKP. But really, the end users in most cases probably won't know about it.
Mm-hmm. And do you think we'll get to a point where it is, going to be used so widely that it will literally be a tick box in your browser? Do you think that's likely where we'll end up?
That's kind of where we're pushing it. So it's already orders of magnitude better. We started purely on focusing on like what we're building right now a little bit over a year ago. But just reading about ZKPs over the last 5 years, we're already orders of magnitudes faster for all these things, for provers, verifiers, etc. If this trend continues, obviously it'll be quick enough. If we speak to large companies, one thing they always mention is like, what is the overhead of ZKPs? And still today, obviously the overhead, there is an overhead. So it really matters what you're building. It makes a lot of sense for Web3 things, Web3 games and Web3 AI, things that need to be, that don't really care about that overhead as much. But regular like Web2 companies, they still care very much about that overhead. And once we get where the cost versus benefit is about the same, we'll see a lot more even in Web 2. So,
brilliant. And yeah, I guess more on the technical side of things. I know you mentioned a little bit, although you're not touching loads upon the scalability factor, you are doing some pretty interesting work with folding schemes, I believe. Certainly, I think might have told the story before on the pod, but when I went to ZK10, one of the questions when you had to apply was, what is a folding scheme? So people like me probably skipped that question, didn't have a clue. Some people, gave a nice answer within the ZK setting, and some people obviously asked ChatGPT, and it came up with all different sort of answers around origami. So you knew the ones who cheated on that question. But it's quite a new technology. What are you working on with folding schemes? Or I guess first of all, what are they? But yeah, how are you utilizing them?
Yeah, I think the idea of folding schemes in general, I've been actually around for a while. There's a paper, I don't remember exactly when it was, maybe 2019 or a little bit before, from Valiant was the original guy's name. And he's the guy who kind of invented this idea of IVC, which is incremental verifiable computation, which is basically like you can take a computation and basically repeat it many, many times to show a result. So this happens in computers all the time, like 1 + 1 + 1 + 1, you get the end result after that. The people actually from Halo 2 were the first ones I actually think did like an actual proper folding scheme. They didn't call it folding. I forget what they called it. It was something else, not folding. But their entire thing was they took a ZKP circuit and folded it with a snark and kind of had the same IVC process from that. But what we call folding schemes today are in most cases actually originated from a Microsoft researcher named Srant Sethi. He's the one who first made the proper terming, I would call it, folding. It also kind of opened most people's eyes to what they can do. It was interesting because he released his paper and like it was dead for a year. Like no one cared about folding whatsoever. And we were like super interested about it, even like very, very early on, like researching and speaking with people about it. But at the very early days, it was just like a gap in the market. People were like, what is this? Like, I don't care. But more recently, maybe 6-7 months ago, people started realizing what folding schemes can do and how they're useful for a lot of different types of computations. As I mentioned, IVC is very good for VM. So a lot of people are trying to make ZK VMs, which is a ZK framework that basically allows coders who don't know about ZKP to code in ZKP with the languages that they already like. But what we are doing with Nova and folding schemes in general, we did the first implementation of SuperNova, which has now grown, and other teams are using what we did and are building much better things on top of it. But the cool fact about folding schemes is since you only have one instance running, or one circuit per step, you can have very good space efficiency. So for other schemes that exist today, like Fry and Starks, they take a lot of memory to prove. So you need special hardware, special computers to run it. But with folding schemes, what you can do is you can actually make it smaller. So you can have it run a certain amount of steps at a very certain size of circuit and do that over and over again. And with that, you have it's basically in the ZKP world, it's the best form of space efficiency that there is. So it's probably the only way to get the stuff to run on constrained devices that I know of currently. So there's two paradigms. One is making things really fast, and now we have this cool thing that's called folding that makes things really portable.
Awesome. And Is it literally, you mentioned there about the efficiency, it might be the speed, the cost efficiency, the scalability. Is that ultimately why it's gained so much traction in those sort of 6-7 months you mentioned? And yeah, why has it increased in popularity so quickly, and where's it heading, the technology itself?
Oh wow, that's a great. I like it. If you don't know about folding schemes, right now where we're at is we have gotten pretty far in terms of research and also in code. So you can actually go look at this code in GitHub now. You can go to Microsoft/Nova potentially is the GitHub repo. So there's hard code out there that people can go look at, which was different from when we started really building it or looking at things that were like very early stage. So I think most of the stuff is becoming more and more production ready. But to this day, there is I don't think Nova that goes directly from a Nova proof to like an Ethereum verifiable proof. So there's still things that people are working on like that. But the dream for Nova is actually parallelized Nova or parallel Nova that you can run in parallel. So you can potentially have multiple machines running a proof at the same time, all with their little chunks. So it could be a phone with a very tiny chunk or a specialized GPU with a very big chunk or different opcodes running on different machines. And that's kind of where we're building towards. But if we're going to go super technical, like these things for the original folding scheme, I think there's only 2 MSMs for multi-scalar multiplications. And if you just focus on making that fast, you can have extremely fast, even the browser, extremely fast folding schemes with MSMs and GPUs. So.
And you were very humble there and very quickly scooting over the fact that you were heavily involved in the creation of SuperNova, which if anyone's listening and listened to episode 1 of the podcast, we spoke to Matej at Lurk Lab, who spoke about SuperNova in glowing terms, and we spoke about, I guess, the acceleration of folding schemes from Nova to SuperNova. Do you want to touch a little bit upon where that was born and why, SuperNova was created?
Yeah, that's actually from the same researcher, Sam Seti from Microsoft. He wrote the paper on Nova and then also SuperNova, and then after that, Hypernova. And I joked on Twitter once, like, what's he going to call the next one? It was Gamma Ray Burst, maybe, is what I joked on. I don't know if people remember that in the Twitterverse, but SuperNova, the cool thing about it is with Nova, what you have is a universal circuit, which means if you have like 50 VM opcodes, you would need to have all those running in the circuit. And so if you only want to use one, you still have to do all 50. So it's pretty heavy. Like each step is 50 circuits. With SuperNova, what you can do is you can pick a la carte the ones that you want. So in our case, it'd be like, oh, this is a very good verifier for ZKML, or oh, this is very good for proving hashes. You can pick the ones that you need to use only, and that's all you pay for. That's kind of why SuperNova is amazing. And once you're able to do that in a parallelized fashion, you can have ZKPs running in a lot of different locations very efficiently.
And obviously, I'm not the most technical person in the world, but there seems to be some similarities between folding schemes and Starks, although they're obviously not, by any stretch identical. But is there potential for them to, work together in a particular way?
No, I like, this is something that is going to be hard for a lot of people to kind of come to terms with. I don't think currently there's any ideas or any solid ideas about how to get the Fry-based world into the folding type world. And the reason why is because Fry and Starks are based on hashing, and those are not additively homomorphic, which is the property we need for folding schemes. So currently, like, there's Binius came out and it's extremely fast. Like, it's potentially the top speed proving system that we have currently. It hasn't been tested yet, whatever. It's a Fry-based or not Fry-based, but it's a Stark-like system. So it also uses hashes. So how do we get that into something that's super portable like Nova, or even onto the EVM, like how to get it onto Ethereum? Those type of questions are things that are active research, and they don't play well together. Hashes and elliptic curves, they're kind of separate, but there are tricks that people use to kind of get these things onto Ethereum. Obviously, we can actually go project by project. Starkware, I think they just pay the gas. It's very expensive. They just pay up the million. I think what they do is they aggregate. So maybe they get like a few thousand transactions together and they just pay as one big lump. And then there's Plunky, which is from Plunky 2, which is also Stark Fry based. What they do is actually have very fast provers for a lot of different steps, and the very last step they have a very slow prover. And that is how they get it on chain. The very slow prover has a smaller proof size. So that's what those systems do. But everything that uses elliptic curves can use something called KZG or Graph 16 and basically get on chain pretty efficiently. And bridging that gap there is currently not very feasible technically, unless you do something like proof recursion and proof composition in very special ways. So I hope that was like easily understandable. Maybe
No,
not.
perfect. No, absolutely. And I think once again, like I mentioned so many times, just the advancements in these technologies in such a short period of time is very reflective of where we are, I guess, in the zero knowledge space. There's so much research going on. I worked with an engineer called Hadas who recently released a paper working with some of the guys from Espresso working on Basefold, it's called. But just the advancements in folding schemes is happening so rapidly, just like it is with virtually every other technology within zero knowledge. Putting you on the spot here, is there anything you are most excited by? Is there anything we should look out for? Is there any advancement that maybe we might not be aware of that's coming at the moment?
Secret research papers that aren't out yet in general. I think a lot of stuff has already dropped, and it's about to be Christmas and like the holidays. So I think Benny is the last big one we're going to see this year potentially. Parallel Nova, I think, will come eventually. There's some work on it with limited factors, but there's probably be a more robust system for doing parallelized Nova. And then that will kind of kickstart folding schemes into this. How do we make it work on a bunch of different machines type phase with parallelization across different proofs? But that's what I'm really looking forward to next year. As you mentioned earlier, like there might be a way to get Binius and these Stark/Fry a hash-based system to work with elliptic curves. Or the other way around, there might be a way to make the elliptic curve systems more efficient. So use some of these smaller fields, which is really pretty tricky, but there might be components within these proving systems like the sum check protocol, et cetera, where when you use smaller fields, you kind of switch back and forth. But there's a bunch of different things that I would say are coming up. But for now, benchmarking, like we have Binius, let's benchmark it against a bunch of different things, or Lasso, let's benchmark it against these Stark-based systems to see exactly where we are.
And that's been an awesome rundown of things from a technical perspective on all things folding scheme, a little bit about what you're working on, and I guess more from a higher level. It's obviously very fortunate to have two members of a C-suite on a call with me and on a podcast, which I haven't had yet. What advice then would you, from your perspective, have for engineers? And I think you said right at the start, you two probably weren't super crypto natives or hardcore cryptographers or anything like that prior to founding your business, but is there any advice you would give to someone who's thinking of trying to break into the world of zero knowledge proofs?
I think most of the people actually in the space are not technically trained as cryptographers. That's something I think a lot of people don't know. Most of these people have like computer science, obviously they're programmers and they have that type of background mostly, but they're not really, like, most of them are not hardcore cryptographers. So the edge that you would need to learn is obviously the gap between this very, in my opinion, not extremely difficult mathematics and what has happened with the history of ZKPs and kind of where we're going. For those reasons, I think a lot of people are attracted to Starks because they're kind of easy to understand and easy to implement. There's a bunch of examples. There's a bunch of systems running in production. But if you want to be a little bit more explorative, definitely take a look at folding schemes. They're pretty relatively easy. There's something called R1CS, and if you get a handle on that, you can understand the first paper. So reading papers, you should be like doing that, obviously, and then kind of exploring code bases that are either in the works or have been in the works about these schemes. So also just to throw one out there for ZK Hack, there's an online thing coming up for ZK Hack. Yeah. So the open source things or community driven ZK hackathons and things like that I think are very good resources.
Mm-hmm. And I know you've hired or you've got a couple of engineers within your team at the moment. Is there anything you look out for in interview processes or applications or anything that stands out particularly for, like we said, maybe someone who's, like you said, not necessarily a cryptographer or cryptography engineer by trade, but you think, has got all the core skill set? Is there, what is it you're looking out for that you might be able to pass on to, like I said, people looking to get into the space?
Yeah, I think one is having a passion to learn is extremely important, especially because most of the stuff is cutting edge and it's moving all the time. So if just comparing it to medical research. Like you need to be up to speed to understand what to do during certain medical situations. Kind of works the same with ZKP. Tech in general is fast, so most developers are used to this, but ZKP is even faster. So it's like having a passion to learn is definitely important. There are books out there too that are open source I kind of want to mention as well. One that is very good by Justin Thaler is Proofs and Args. I don't remember the full name of his book, but it's free online as well. And that's a very good resource to get started from zero, basically, up into kind of like production speed, up to date. And he also has videos on YouTube that were recorded through these sessions, which is a very good resource. But for hiring people, definitely like the willingness to learn. A Rust background is extremely helpful. Most of the stuff is written in Rust. There are a few Golang ones, but most, like I would say 90% or more in Rust. And the ability to look through code and kind of discover things by yourself is pretty important.
And well, two reoccurring themes there. One, Rust being used in the cryptography space. I don't need to touch upon that any more than I have done in previous episodes. But yeah, obviously interesting to see that you guys have been implementing that as well. And yeah, supposedly, if you want to get into the zero knowledge space, just check out Justin Thaler is the number one advice that a lot of people give as well. But that's been awesome. Is there anything else you wanted to cover? I can share some resources and stuff, but yeah, I've certainly spoken and we've touched upon an awful lot that I wanted to chat about. Is there anything else?
Yeah, check out ICME.io to learn more about us.
Absolutely. I'll share all the relevant links and bits and pieces in the comments and stuff. And yeah, Wyatt and Houman are working on some awesome stuff. By all means, check them out. And really looking forward to seeing what you guys have got in store for early next year. So yeah, thank you so much for your time, both. And really enjoyed having you. And yeah, take care. We'll see you soon.
Thanks so much for having us.
Cheers. Bye.
Bye.